Hi everyone, I am ZJ van de Weg or Zegian, depending on your Dutch. I'm the CEO here at FlowFuse and I'm very excited for this webinar session and I want to thank you all today for joining us. So today we're going to talk to Klaus Lansdorf. He is the CEO and co-founder of Ideationware. He is the creator of the main OPC UA nodes for Node-RED and plus for Node-RED packages. And with those packages, he works on OPC UA integrations for Node-RED already since 2017. Before we dive in completely, there's a couple of housekeeping notes. This webinar is being recorded and it will arrive on our YouTube, I think, tomorrow or so. So if something goes too quickly, tomorrow there's a chance to pause things and reenact the demo that Klaus is about to do. If you have questions while we're in the webinar, there's a Q&A panel in the bottom bar next to chat. Please use the Q&A one, not the chat one. And then after the session ends today, a quick survey will pop up. We do appreciate your feedback so we can learn and improve the webinar for next time. And those were all the notes. That's also all for me for now, and I'll just hand it over to Klaus.
Perfect, then thank you very much, CJ. And yeah, nice for having me. Oh, thank you for having me here in this webinar. I hope we have really good questions, also some deep diving sometimes. I hope it's not too technically, because we have the idea to show it how you can use it simplified at the end, and how FlowFuse and Node-RED and all these tools can support you in doing this. Yeah, but maybe in the start, we want to ask you a tiny question. So we will start with a poll, because it's nice to have you as an audience here. For us, it's also great that you take your time here to join this webinar. And it would be nice for me to know, where have you used OPC UA so far? Because it's nice to know a bit about the audience at the end. Are you in production line or live systems with OPC UA, or just testing environments? We have also a lot of people, they're working in development and prototyping with OPC UA. Or the last option is, I haven't used it yet. I'm here to learn. It's nice to have, especially these really new people or newbies, let's say, maybe, in the topic. But also, if you're really an expert, maybe, I think it could also be very interesting to see some things, how I use it, how I can work with these available tools. And I think there's a lot in. Okay, then we have the poll in here, and I think we could start, or is there something else we have to check for this? I think we can really start here from that point. We see the polling. Yes, okay, nice. We have also some people are new here. Really, really nice. Perfect. Okay, then we have really, really different, or let's say, heterogeneous
Varying results.
Audience, yeah. So that's really, really nice. And I would say, let's start. So we have not a lot of time. OPC UA is really a big topic, and I think we could really start with some points, so that I also have the new people here to give some insight for OPC UA. And so I start with my slides, okay? So first, about me a bit. As CJ said, I'm working with OPC UA a long time now. For me, I started with Modbus in 2016. I had also some contribution to the original OPC UA contribution package together with Mika. Mika has also a great webinar here for FlowFuse about this package. So we're talking more about different options here. I also started really to develop for Node-RED in 2015. And was really going 2017 to create the IIoT OPC UA package for Node-RED, because we have different interests. So Mika was more to say, hey, we want to have a really easy to use node, the best case, one node for the client, one for the server, which is really great as an idea. But for me, it was interesting to show people, how can I use OPC UA more as a toolbox? What's all in? And how can I learn OPC UA? That was the let's say the first step, how the idea was born to create the IIoT package. And you see, you have a lot of more nodes, what's in there, and it shows you what are the services in and so on. And maybe if you learn more about here in OPC UA, you will see also more what's in that package at the end. Yeah. Yeah, from my side, I created also 2017 my first company, Bianco Royal Software Innovations. It was later with my brother-in-law to create Iniationware from it as a bigger company. And today we are 5 years old as a company, and we are partnering with FlowFuse since 2023. We were really interested as it started because it's nice to have a tool to control Node-RED in environments. And I also created this year a company, Bianco Royal LLC in the US, so that we also can work with companies in the US. The focus for today is really this 4.0. Many people talking about it, but we also talking about the beyond. Because energy, buildings, and industry is really, let's say, the focus in the 4.0 industry. So that means all these topics would we have to control things, to automate, to make them talking together or working together, is especially here also in 4.0, where you use MQT and or OPC UA mostly. Sometimes also BACnet. If you are more in buildings, then you maybe know more BACnet also for OPC UA connectivity. And you have to control a lot of things, robots, cameras, routers, a lot of things what you can use OPC UA for, and also to control them or to send out sometimes also firmware. The original idea of OPC UA was to make things easier because we had a lot heterogeneous and differentiated OT world, and it was existing OPC Classic, which is Windows or Microsoft platform, what it used, the COM platform. And the OPC Foundation said, hey, we have to be more independent. We need security by design. It should be extensible and also give the ability to create comprehensive information modeling. Yeah, that was what you also can find here on the reference of the OPC Foundation. But that was the key where it started from. And then we had this core OPC UA in the very beginning, which said, okay, we have two things in the industry. First is the transporting of data, and the other thing is data itself, in the best case, information models. If you have an information model and you can transport the data, then the next step is you need services. And the service could be read, write, browse, but also calling a method. Because calling a method is also important to give some parameters, call the method, and that's also what we like in programming. We can get a result. Does it work? Does it not work? Is the parameter correct or something like this? And there it started that OPC UA was not just a protocol. It was really a technology, what you can use. And then you get also some core features like data access, that's known mostly, but also alarms and conditions. Historical access, that means you can also record directly in your OPC UA server some historical data, and you can request them at time when you want to have the data. And you can also provide some programs directly in the server, also methods, as I said. And the next step is then to have these specifications of information models, because the idea was in the industry every time we want to have, in the best case, the same situation. We want to have something where we talk the same language, where we can bring in our domain language of connectivity, but also of information modeling. And that's where OPC Foundation was really investing since 2010 now, so 15 years of work of those people. And a really good thing is also you can go on top of this. That means you can really create your own vendor specification. And maybe it sounds complicated, but it isn't. You can really start with documents. You just download the documents, build a team, and say, hey, what is our specification? Which specification could we use or reuse, or where can we go on top of it to create our implementation or our specification so that we can communicate with machine builders, but also with IT people, so that we close the gap of OT and IT with our specifications. Sounds a lot, maybe, I don't know. But the next thing here was the actual update of OPC UA. They decided to go to rolling releases. Means we have now version 1.05, and for the OPC Foundation, this is also what shows what it was before, the model what you saw, and what it is today. It looks really the same thing, let's say, but technology could change. As you see here, in the first time it was just client server. Today we are more interested in pub/sub, means like sending data to MQTT directly. And it's not a problem, especially from that separation of transport and data. You can just say, okay, we need a new transport opportunity, or we need some really new technology because a lot of people in the industry using it. And that was the thing where I thought 2010, that's nice. That's a really great technology at the end, because if a lot of people are interested in the industry in that, then I just have to wait, or maybe I can bring some people together if multiple companies are interested in, and we can bring this to life inside the technology of OPC UA, and we can bring in some really new. And pub/sub was the first example, I think, what made this big change at the end possible, and showed that it really works. Now that a new technology, completely different architecture at the end, what you could build now, yeah, it's just a question of time and people, they work on it. Or maybe I click every time the wrong button. What's really great here also in the companion information models, I don't know if everybody understands that point, but there's a lot of work in that, because you need minimum 3 companies to build a group of experts. They are talking about companion specifications. And that means you have really experts working on this. And there's a lot of work, more than 10,000 days, I think. I think more at the end, because we have 15 years, a lot of groups, minimum 3 companies means minimum 3 people, I think. In tinier groups, we have mostly 5 or 6 people working all the time on this. And it's ready to use now. You can start with a mandatory model, which was built by experts. They just said, this is nice. If we have this, we can work together immediately. So that means a PLC programmer can take that companion specification, have a look to it, program it in that specification kind of how the information model is built. And also the PC programmer can do the same. And it was really in, I think, 2021 that we really did this with Siemens programmer. We just gave them an XML file of our model idea. They imported in this in their Siemens PLC, and then they started to develop. And after some time, each developed the position of what we have to do. Then we just met to make the commissioning and put it together, and it worked after 15 minutes. That was really nice, because we really talked not a lot about what is the value, what is the data type, what is the infrastructure where we sending data out. So it was just using at the end a specification in that case, and bring it together, and it works. And that means for you, if you make your own specification, or maybe some just changing of it to use some optionals, it took you just some weeks or days to do so. Okay, and could be very complicated, as OPC UA is really ready to use from sensor until the satellites. Means that we really have every area in the industry where you are able to use OPC UA at the end. But you have to check, is it the right tool for your use case? Because other protocols like BACnet or MQTT or Modbus, like in the energy field, are working also nice, have also some security today. You have security for Modbus, for BACnet, but also for OPC UA. And the main benefit is mostly when you use these specifications. So that there it makes it makes a lot of sense for you to bring in OPC UA. Because if you think about some Modbus register, you every time have to check what is the register for, what is the value, whatever. How to combine maybe also all these 16-bit registers to have 32 bits and so on.
Klaus, one question so far on OPC UA being a standard that is supported by multiple vendors. Can you touch on to what extent is the standard, and is it being used by both Rockwell and Siemens, or is there a sort of like competition going on there?
For my case, there are some more, let's say, working together. There's also that we have some harmonizing in the OPC UA group. That means when you have like the device specification, all vendors try to support that specification, and you are ready to talk with nearly all devices today because the vendors are accepting these device specification, and mostly it's just that you have some more optionals, but the core, the mandatory, that's great, is it's mandatory at the end. Yeah? You cannot say I don't do it, or then you are not really spec conform. And that means it's not, from my perspective, a challenge or some competitor stuff. It's more working together and then maybe differentiating from the optionals what are the other values. And from the
so it's really a specification these days which is industry-wide in support.
It's industry-wide in support, and you see more and more devices which really comes ready to use with the device integration minimum, or also in PLC sometimes as you have like this UAFX or something like this. You see more and more integrations over time, which get more complex or give you more abilities to hide the complexity again. And this is what I want to explain here, that you have one side is the FX, which stands for field OPC UA, because you have really different things you need at the end. Yeah? If you are in the cloud, it's CX. So if you read about OPC UA UX or CX, then it's cloud, which means you can communicate with Azure Data Center or AWS. And on the field, you have your PLCs, HPCs, IPCs, all these devices and sensors. And these are the two categories now of, let's say, OT and IT, and you can bring them together. And that's the simplicity at the end, what they also try every time to do from the OPC Foundation, working with the companies together, making it easier, harmonizing all these groups that you have in the best case the same things that, let's say, something is maybe built on top of device, that the variables which are mandatory or methods are also mandatory at the end on the corresponding or inherent specification. As you see here, for the OPC UA FX, you get some new features like safety, motion, instrumentation, IOs, and so on. So you see also the same structure at the end from all these, from the core to the new rolling releases, now also to a really specialized kind of OPC UA at the end. And that means the architecture works. That's really a technology which has an architecture that is extensible, where you can change things, where you can bring in things, what's really needed. And if the whole industry need that technology at the end, or these integrations, it's ready to use. You don't have to think a lot about it. And all these mandatory things will exist, will help you to go up and running in a minimum way. And Humati is also a group for me. I really like the work of Humati, especially machinery, because I'm working with ISA 95 since, I don't know, 2007 or so, a really long time. And a great thing here since last year is that Humati really brought that idea of controlling machines through OPC UA, that you have also a job management now ready to use. That means you can send out a job via OPC UA to your machine. You have a job list on the machine. You can control how that job list is working at the end on the machine side. And you get also process values, you get results. It's all defined, and you can bring to your machine material, personal, equipment, all these things what ISA 95 defines for MES or manufacturing operations management. And that also, if you have something like these complex standards, and you see how easy it would be provided now through OPC UA, because a group of people making this work for all of us, defining how to start, how can we bring this to the next level of 4.0 to really start some nice integration of working together between the ERP, MES, and at the end the machine and robots. And we see it also like here in the plastics and rubber machinery. They going on top of it. This was just also a slide to show you more, to say, hey, there's the build information model basics. There on top, we have the machinery. There on top can go, let's say, also an industry on top of it, to say, yes, it's nice to have this machinery definition, but for us, it's a bit different. So let's working together to define how could this be, because at the end, it would be cheaper for all together, because the machine builder can have easier integrations on their machines. You are ready to use it if the machine arrives on your site, and that is really a nice thing of OPC UA. What is not easy to find in other technologies at the end. When you think about MQTT, there's a unified namespace. It's absolutely nice because also based on ISO 95. That's why I also think it's a good idea to use it as well. And when you bring all these together, but you have to define, as you see, something like UNS also on that technology, so that people can work together and talking about the same at the end. Now, and if you see how all these companies have an interest to bring this further, developing the next step of the models, and all the others are ready to use it. And the machines or the devices also provide that specifications, in the best case, out of the box. And that means you are not alone, from my perspective, because doing all these complex things.
Klaus, you briefly touched on MQTT there with UNS. Does OPC UA have a similar message, like a delivery guarantee on those messages like MQTT, like with the quality of service setting?
At the end of OPC UA, I think it is absolutely ready, or the message is sent absolutely to, because you have not a quality of service directly. I mean, in the protocol. You can work with quality of service to manage how fast the protocol is handled in your network at the end. But as I know, OPC UA really brings the message to the device, because you have all these auto reconnecting. That means if a client and the server are connected, then they every time will reconnect if the connection gets broken, and all messages or what were in between could be lost if you have not historical access or something like this. But this is exactly where you have these mechanisms for. For the pub sub, I'm not really sure. I would say I never used it with the actual integration of also having JSON messages in this. I used it the last time where you have to send binary OPC UA stuff through MQTT brokers, and it was not something what I liked. So that's really a point where I would say, hey, there's some stop for me, pops up. Maybe there's someone else who's really familiar with. So because my interest is more working at the end directly with MQTT things together. And so many pops up is not.
Yeah, thanks for diving in the quality of service setting on MQTT and how you do that with OPC UA.
Okay. How to start with OPC UA. That was the idea of this webinar today. Also, we want really to start with FlowFuse, the first point, not with Node-RED, because if you are thinking about the industry, also in my case, it's not easy to deploy on multiple devices. So you have also maybe Docker or some tools on Docker based on that, where you can deploy all these things, but it's much more. And the idea here is also with OPC UA, we start with FlowFuse here. We have Node-RED inside of FlowFuse with a nice shell from FlowFuse here, that we can deploy some remote agents to bring our instances easily to remote devices from the cloud. And you can also have an installation of FlowFuse directly in your data center if you want to use it this way. And the great thing is also you have a great community with a lot of packages. Means if you type in OPC UA, we'll see it later, you have not just one package, you have a lot of more packages, but we see also some different way today how you can use it. So that's the way we want to start with OPC UA today, because we want to go over to some demo to play around with this. And we have it here, as you see. Maybe it's too small, I'm not sure. But if you go really to the manage palette and type in OPC UA, then you see at the end 17 packages are available. Some packages are existing from our side, from my side, which is especially the Node-RED contrib OPC UA server, the IIoT OPC UA package. The interesting thing is also for me that FlowFuse supports technicals to build enterprise integrations, automations, and autonomy based on open source software. That means we have really open source software, open source contributions. It's a no-code, low-code platform as a service that we can use here. And this is great for integrations and especially also for us in communication through code. That means if we can give technicians on site the ability to express their ideas in FlowFuse flow at the end, it looks mostly really crazy or ugly or whatever, but you will see the idea, what they have in mind from their practical knowledge, and that's really nice that you can go deeper with people, give them some tools on site in their hands to work with, to play around, to think about, and especially if you bring OPC UA in that, they are really ready to communicate with a lot of devices, PLCs, and so on. And that makes it much easier for them to connect devices in the field. And if you have these PubSub integration at the end also, or an protected OPC UA server in the cloud, you can also send the data to your data center or to the cloud. And that's where we start. We have some client and server at the moment in the most packages for FlowFuse Node-RED. And we could also use models. It means that XML, what I mentioned, for working together with PLC programmers at the end. But we have also, as I said, security by design, that we can sign and encrypt data or just sign our data. And the idea was also from our package at the moment to have templates ready to start, also based a bit on these specifications of OPC UA, that people can really start fast. A tiny overview about the architecture what I built here with FlowFuse and all the devices what we see shortly then is here. We have an MQTT broker at the end which is working. We have FlowFuse ready to control on the IT side. We have a special layer of OPC UA so that we are also able to communicate from a hosted instance inside the cloud at the end. And we have some edge devices. They could build also some aggregator, some wrapper for machines which maybe have no OPC UA connectivity or have just these switch on ugly OPC UA models which is really not easy to work with, so that you can give also new names, new infrastructures on the OT side. Because sometimes it's really a problem in real world projects that you get an OPC UA server and you have something like ABCD, whatever, like 20 or 30 years before in a PLC, and that's something nobody can work with, or what is not really an information model at the end, because it should be readable for humans and machines when you have a really nice information model at the end. And I use the FlowFuse agent, as you see here with the FFA. I put it on the devices here in my environment, and I have also a strict separation of the OT and IT at the end, what we can play around with today. Okay, so I think it's a good timing here to start with. And I would say let's go over to the demo. Or do we have a question also until now?
We have two open questions.
Okay.
One is about extending the specification for example, Euromap, which is about injection molding machines. Would you consider those vendor specific, or are those extensions on top of OPC UA?
The extension for vendor specific is if you have a really special thing for you where you do not find anyone else to work together on a specification, but if you find multiple companies or other people, they say, yes, that's a great idea. It could also go back to the existing specification. That's what we see every time. That is not just building your own vendor specification away. The other way is also, if I understood correct, to bring things back to the teams. Like also Umati is really listening to people from the real projects to say, okay, that's a nice idea. We can bring it in the next version.
Okay. And then one more question, which is, like you asked, very deep technical. Is OPC UA Classic based on Microsoft Com/ActiveX and OPC UA based on WCF, which is the Windows Communication Foundation?
I would say no. The idea of OPC UA was really this unified architecture where you say this web technology. The first thought was this OPC TCP protocol at the end, which is binary. But the idea was also to have this web technology ready so that you could use REST or HTTP, HTTPS. You can do this today to bring, let's say, a reverse proxy in front of your OPC UA server that you really just have to translate a bit between these. And the idea is more being independent from Microsoft stuff at the end. So it's really, and also from protocols. So.
Okay, then it's a demo time.
Perfect. Okay, then I try to switch over here to, so you can see also on the right side the PLCs on which is the one is a starter kit we can play around with, and the other one is a PFC 200 from Vargo, the other one from PLC Next from Phoenix Contact. And I think these, for us, these are the two PLC devices we find in the field or we're working with. And so it's good for me to have this. At more in the background, you can see here a tiny cluster. This is the Pi 2B cluster of 3 Raspberry Pi version 2B. And on top of it is our Jetson Nano. And the way here for me was it to integrate the devices here as remote instances. Today I have some trouble with the Pi 5 AI cluster to get it so you see it also here. That's nice that you see that some devices are not working, but you can also see all the devices when they were online, if they are running on all these. And you have also the ability here to go to switch on the developer mode and to open up directly here to go into the instance running on our Raspberry Pi here in the office. And that's what I am using here. And what we see here is our Phoenix Contact. We have also some, let's say, web UI. And we see here there's nothing switched on. If I really go here to switch things on, we see this also directly here. And we have some analog value, what we can turn around here, this to see something changing. And we have some tiny PLC program with this for our trainees. So our trainees have to do this every time. It's the first thought to go with, and to first program PLC and then later learn how they can use OPC UA to contact or connect this, and also to control this at the end. That's the idea. And this is what we connect here. And especially here, it's really easy with our package at the end, what you can just use privately, because we have this P4R B2B community here to use it. And the idea here is just to select a template. As I said, we have here some unsecured or secured and signed. Then you get just JSON. So this is also to copy. You can manipulate this because in the last time we had every time some UI component for this to control all these parameters, but it gets more and more, and we have also rolling releases today. And that was the idea to say, hey, let's go the same way as we have it here, like Node OPC UA provides it in the code, that we really can give all the parameters what Node OPC UA gives you. That means if we don't update maybe the UI, you have not a problem. You just bring in new parameters or you change the infrastructure here. It's easy to update. We need also some certificate stuff, so you can do it also from FlowFuse instances directly, that you can change your certificates or you can have an insight to your certificates. This is, I think, a really helpful thing, especially also if you go with multiple devices like 10 or 30 devices. Then we have also some tree view that you really can click here to see some data from what's available in the machine. That's here from that Vago system where you see here the B501. And we have here also the node name so that you have an insight which node you have there and what you can connect to. And we have also some monitoring here that we get the data. That means we can just monitor subscriptions. Do it this way. That's also sometimes when you have pops up and subscriptions. There's one, the old subscription named, which is really called so inside the OPC UA programming. Mostly that you have a subscription for monitored items, but it's not pops up in that case. It's just monitoring. And the idea was also here, what you could use also in programming directly in FlowFuse editor, that you can go with unified message structure, we said at that time. So that means we have every time OPC UA items and every time the metadata. And metadata gives you more insight about what we gave to the OPC UA backend at the end, and what are the results at the end is what you see in the OPC UA items, and especially OPC UA items length should be make it easier for you and simplify it so that you don't have to ask every time the array again and again and again. That means you can just go into the metadata and have an insight of, do we have OPC UA items, yes or no? And how many do we have? Because the most question in programming, doing things, making decisions, and so on. And you get also an information from which type of service you got these data. Okay, this is the package a bit to see. You have some more notes here, but we don't want to talk just about the package. I want also to show you something more. And this is,
while you're at the editor of it though, can you display the tree map of the nodes with the tool that you built?
This tree map here.
Yeah, there you go.
Yeah.
Yeah, that's one of the QA questions. So while I had you, I had the opportunity to get that answered. But yeah, onwards, Klaus. Thanks for answering.
Also, maybe I just did not understand. Can you repeat it, maybe? Or...
Oh no, yeah, you already answered the whole question.
Ah, okay, perfect. Sorry, sometimes.
No, yeah, you're good.
Let's see. Now we can also go to our hosted instance. So we have these differences. Hosted instance is directly in the cloud working. That's the instance what I started now, and I want to go deeper with you that you not just can use these node sets, because we have IoT OPC UA, we have our people in our OPC UA stuff. We have also the normal OPC UA package. We have well documented situation about all these, but you can also go a nice way to work together with just the function node of the FlowFuse editor. And that means you can also just import, I think some people that are more familiar with Node-RED know this option maybe. You can just import Node OPC UA here, and that's it. And then you can start with the onStart, which is really nice for me to program directly in the FlowFuse editor. That we can just set up here with the Node OPC UA stuff. And if you see all these examples on GitHub or in the documentation, there's also a nice book on LeanPub, what you can buy about Node OPC UA. And yeah, with that, you can really start here to play around and to implement things. What has to happen on start? We have the context also here in the FlowFuse editor, where we have to remember our object or to keep it alive. Because if we just would say, okay, we program all here and that's it, then we have a problem that this disappears, this object, and will be deleted by the garbage collector. But if we put it to the context of the editor, then we have it available also later on stopping. this thing to just get it from the context back, and to call also some function like the shutdown here for the discovery server. Or we can also send a message to that node to get some answers like endpoints or so. Let's check this. Hopefully it works. And it's really a big structure or big infrastructure. I have not connected a lot of servers here, but you see the endpoints here, you get some information, and that is really the easiest way you can go with OPC UA in the FlowFuse editor. And now you say maybe, oh, but it's not so many code, but maybe a machinery server or some device server is much harder to do. But for I would say it isn't. You have also just to import the node OPC UA, and you can take examples from JavaScript in the best case here, because we have, no TypeScript support at the end. But we just create some tiny things here. We have also to work with the promises of node OPC UA a bit, where you have this old ability of going with then, catch, and so on to handle your promises. And then you just type in what you can learn from node OPC UA, and you can bring also some messages that you get informed from the debug window here, that you see something appearing here. And also here you see that we finally set the server context. There's no message on the server at the end, but as you see here, our client, so the client is something I not programmed at the moment because it's a bit more to do a client. You can do it at the end in a function node, because a function node, if you do that work, is really easy to copy, to import, to export. It's also nice from the FlowFuse editor that this work to be done is a third of doing it once. That's really nice in the digital, let's say, integration, that we have to do that work just once. And also here, it's easier for me to show what's the inside. As you see here, I did just a tiny device integration here for machinery. It's not a complete machinery at the moment, but it shows here that you can have a type, just make an instance of a type. It's also a very powerful thing of OPC UA. I didn't talk in the first minutes because I have really to bring some points if we need it. Otherwise, we would just talk about theoretical stuff. And here it's really nice because I just have to use the device type from the existing specification from the OPC Foundation. I make a new instance and I have all these parameters here ready to use, just to fill it out, and that's it. And then you can read these values. Everybody can read that values which have access, or if you have for some points really easy access here, then it's just connect, read the data, and start. And you can also go if the discovery service is available, or discovery server. That means that you have this default port of 48, 40. And you can just call from node OPC UA something like find servers on network, and then you get really a discovery of the existing servers. At the moment, I think it would not work because I never registered some server at the moment directly on the server. But with some more time, I would have it would work. And it's really well documented in a lot of tests and samples what we have here in node OPC UA as well. And you will find this here in packages of the source code of node OPC UA. When you go into this, there are a lot of examples in the OPC UA address space package. When you go there to tests, you see a lot of things how to work with this. And you have also these test helpers here, where you will find a boiler example, a lot of code how to do this. And all this code, if this is here it's TypeScript, you have to transport it a bit to back to JavaScript, I think, for the function node. But you will find also some JavaScript stuff normally you can use and you can play around with. Otherwise, it's also here in the node OPC UA samples. let's go here for Node OPC UA samples, is also a great point to start with. If you're really new to OPC UA, you will find here some, as I said, device server, how to create that boiler example as a device server. You see here we have some requirement from the address space, because the address space is the information model what you can use to create very human readable information structures which are hierarchically organized, and which is also explained in the specifications. Like here, when you go from a DI specification for a device, it's clear which values are here to fill up, or how things working. And like here, if you see the parameter set, which is an optional thing of the device specification, that means you get a flat list in your device in the best case from all or about all parameters of the device. So that means if you have some more human readable infrastructure in your OPC UA server, which is logical and hierarchy organized, then you can also provide from that specification a flat list of all important parameters to everybody which wants to communicate with your device. And also the same thing for method sets, or for the method set that you have in the method set all methods which are, let's say, important or existing. That's a bit the decision of the creator, because it's optional, who's creating that device server. Yeah, but at the end, it's really helpful because you don't need to know anything about that device. You just connect, you read out with the browse service the parameter set, you read out the method set, and you know everything about that device. And if you think also ahead to AI, it's really nice to use for AI, because they can start with these. And I think we will see more, because that gives a lot of benefits to use also optional things to support, let's say, autonomy at the end. Okay, that was a tiny dive into with these things. Because we talked about AI, I have also asked the AI of FlowFuse play something around here to give this prompt: build a Node OPC UA client and server DI spec example with 8 ins, also digital ins and outs, and let them connect secured by signed and encrypted username and password. I got this thing here. So the problem is you have to send a message in that so that it works. And it was not really correct, but it was a nice shot to see, okay, what's important, what do I need? And I think if I would have more time and get more precise information, I think the AI will do a more working example and a better job at the end, because Node OPC UA has a lot of examples out there in the internet, and I think that AI can really help you out with parameters, with creating things. And what I did is just taking the code today and put it into something as we saw it before. Just give the Node OPC UA package, put the part of creating things into the start, so that we have our session, client, and server in the context, that we also could stop that context later. And if I send a message to that thing, I can also get some output of reading data from this. Let's check, and that's it. Boom. It's really something connected. So because the start of the function node has prepared all the things we have to start, the server started, the client is connected, the session is running. And now if I send a message, I can read the options and the variables. A last thing maybe here is also to play around with a dashboard. So for that I really used our nodes because it's much easier and faster. It was a tiny room climate meter, and here I have also the ability to go to a dashboard from a hosted instance, and that means we have this tiny dashboard here. At the moment it's not running, so we are not connected. the data are not changing. And you see it also here that monitoring, what I'm using for a session monitored items, I can just insert this one here. And that means what now happens is the server is creating an item for you inside the server and having a look for these variables, and you get just the answer of data or send data if the value is changed. And that makes also OPC UA today a very, very small protocol, because in the very beginning we had a lot of discussions. Oh, OPC UA is so big, we have so many things in that, our network is going crazy, whatever. But at the end we built really huge systems with bringing all to OPC UA, the robots, the machines, the lines, everything. And it is really, really fast, and the traffic is absolutely low because we're just exchanging data if they changed. Yeah, and this is very different to other protocols from my perspective, because you can trust at the end these, because the connectivity will not just break, it will come back. You get all the data as long as you are connected. If you lost the connection, you can record it maybe for you on the client. And in the best case, you have your for important data created a historical data access, so that you can say, hey, sorry, I want to have the data of that time span back, send me the data. And what we see also here in the dashboard, we can give more information, like what is the unit, and all these things. Also, what is the high, what is the low value, what is the high value, low value, and all these things what you need in production is ready to use, let's say, from analog items, what we have as a type in OPC UA. Yeah, and that makes OPC UA absolutely simply or simple to use at the end for me, because all things what I need as a programmer in the industry, if it is energy, building, or industry for robots, whatever, exists. There's something existing. And if not, you just have to find some friends to think about why it not exists. And if it gets relevant to the market, to the industry, also you get some support from the OPC Foundation to make that thing happen. Now that we have a specification, and also that is just the effort of doing it once. And then everybody on the planet can use that, and machine builders or device builders can bring that into their devices ready to use, and you can just start. Now, okay, that was an overview.
Yeah, a couple of questions, Klaus. Someone is really inspired and wants to run their whole home automation suite on OPC UA. Have you gone that far already yourself?
In my home, it's
Yes.
mostly Modbus.
Okay.
Because I have just some like my heat pump or something like this, or the energy things are mostly just supporting Modbus. But what I creating, let's say, mostly is OPC UA in the industry for me. Because as I said, also in the MES field, it's much easier. You can connect with SAP or other ERP systems today. You can connect to alarming systems and maintenance systems. You have, like Pessler. Pessler is doing just to create a layer on your factory completely to collect all data from all these different protocols in the field, to have unified alarmings, that you have alarms and conditions just ready to use on OPC UA, and things like that is really, really nice, because making things easy.
Yeah, I think the home automation was a bit tongue-in-cheek there.
Yeah, absolutely. For home automation, I think it's easier to go with some tinier things. It would make sense at the end if somebody says, "Hey, this is the home specification." Maybe that would be nice. Maybe there are some people to bring that together and say, "Hey," because the interest is there. A lot of homes could use that, especially if you have a lot of things to control. When you think about especially energy at the end. But it's there you have the same problem at the moment as you had 10 years before in the industry, or 50 years. That they are really proprietary mostly. You have just ugly data information. All
right, and then one question: if the OPC UA compact client control node is also available outside of FlowFuse?
Again, the compact node? What do you mean?
Yeah, there apparently is an OPC UA compact client control node.
No, this is just really these nodes are really from the people in our B2B community, because we have so many work to from that rolling releases at the moment, so that we decided to make this for a community. The idea of the community was that it is not so expensive, but we can really take care about this. It's also the idea of open source at the end. Because you get the package, but we have to take care, and it's a lot of work over the years. So we have 4 people working now on this to bring this every year to the next best version, and to bring also these specifications directly to your hand. When you see here, we have some demo servers to play around with, to teach also maybe, or to maybe test your software with it. So that's the idea at the end, whatever the community wants to have here.
Okay, yeah, thanks. There's one question if you can share these flows. I think it's most practical if you export the flow and then we send them in the follow-up email to every participant.
Yeah, we just share the flows where our node is not in there, because otherwise you cannot do a lot of it. But we can share all these other nodes. It's no problem. Yeah.
Yeah, and the most popular was the tree view.
The tree view is really a part of our node. I think also that the OPC, as a node OPC UA, Stair 5 has also some new node for this. But this is really just part of the of our client, let's say, because we created a client, that's so nice every time in the editor. There's this tiny node here, which looks really not so important, but that's the whole complete client at the end, and also server mostly, which brings a lot of functionality. And this control node here is just like a remote control where you can play around with the client and use like a bigger client with the UI.
All right. Yeah, thanks a lot, Klaus. This has been great. So for everyone else, please don't leave just yet. There is a short survey at the end. And if you can take a minute, please provide us with feedback, and so we can improve the next and future webinars. Klaus, massive thank you. It's been great to see the demo. Then lastly, if you want to talk about deploying OPC UA nodes with Innovationware and FlowFuse, do reach out to us or book a demo on our website. The links will be dropped in the chat if you need them. And yeah, thanks again, Klaus, and everyone attending, and see you all on the next Node-RED deployment.
Perfect. Thank you very much.